Okay, good afternoon dear students. Today we will solve some important questions of continuity of the function. And some student asked me some questions related to the continuity of the continuity inside the interval. And also one question asked me by a student, the limit x tends to infinity sin x upon x. So the answer of these questions are, let us take a function fx equal to x plus mod x. In this function, if we want to find the continuity of this function in the interval x belongs to minus infinity to infinity, if you want to find the continuity of the function in this interval, then we have two cases for this function. One is the first case is we can consider this function first function and this function second function, and we know that the sum of the two continuous function is always a continuous function. Sum of two continuous function is always a continuous function. Okay. Or other cases, we can solve it by the method we know that fx equal to, we can write this function fx equal to x and the value of this function x when x greater than equal to 0, and x, the value of this function is minus x when x less than 0. It means this function convert in the form of 2x and this is 0 when x greater than equal to 0 and x less than 0. Okay, it means we have only one point at which we can find out the continuity of the function. That point is 0. So at x equal to 0, the left hand limit of this function is limit x tends to 0 negative, and when we take the 0 negative, then the value of this function is 0. It means the limit of this function is 0. And similarly, the right hand limit of this function is limit x tends to 0 positive and f of x. In this case, the value of the function is 2x, and this is x tends to 0 positive and 2x, it is equal to 0. And similarly, the value at the x equal to 0 is 2x, and at x equal to 0, the fx equal to 2x, and when you put x equal to 0, then this function is 2x. It means the left hand limit, right hand limit, and the value of the function is equal. So the function is continuous at x equal to 0. We have only one point at which we can find the continuity of this function, and the other point, this function is continuous at every point inside the interval minus infinity to infinity, and this function also continuous at every point inside the interval minus infinity to infinity. It means this implies fx is continuous at every point x belongs to minus infinity to infinity. This is the answer of this question. This is continuous at every point inside this interval. Or another method, we can solve this question by, because the sum of the two continuous function is continuous function, and this is the continuous function in the real line, and this is also continuous function in the real line. It means the total function, the sum of this function is continuous in the real line. Okay, and the next question is, this is the next question. Some students ask me about this question. What is the limit of sin x upon x? Okay, this is a very interesting question. In this question, we have when we put infinity in this point, we can convert this function in two parts, one upon x and other is sin x. Okay, and when you put infinity in this part, suppose that this function is gx and this function is fx. When you put infinity in this part, then this part is 0, and for x tends to infinity, this part exists some finite value, because the graph of sin x is this. Okay, and when it tends to infinity, then there is some finite value. of sin x. So this is the some finite value in the real line, and if the second part is there is some finite value, this is 0, then multiplication of this is equal to 0. It means the limit of this function is 0. Okay, this is the answer of second question. Thank you.